let's solve these questions on electric circuits from November 2020, paper 1, question 8 from DBE. Okay, this is the question 8 on electric circuits from November 2020 first exam. Okay, so question 8. A battery with an internal resistance of 0.5 ohms and an unknown EMF is connected to 3 resistors, a high resistance voltmeter, an ammeter of negligible resistance as shown in the circuit diagram below. The resistance of the connecting wires must be ignored. Okay, you are given this electric circuit. Okay, now 8.1, define the term EMF of a battery. 2 marks. 8.1, EMF is the maximum energy provided or the maximum work done by a battery per coulomb or per unit charge. Okay, so the EMF is the maximum energy provided by a battery per coulomb. Okay, now 8.2, the reading on the voltmeter decreases by 1.5 volts when switch S is closed. Okay, 8.2, give a reason why the voltmeter reading decreases. 2 marks. You are told the reading on the voltmeter decreases by 1.5 volts when switch S is closed. So when the switch is closed, now you allow the current to flow in the circuit. So this is the main switch, okay, which is controlling the current from the battery. Okay, from the battery. So this is the main switch. When the switch is open, you are going to read the EMF. Now when the switch is closed, now you are going to read the supplied voltage to the external circuit. So there is a decrease of 1.5 volts. Why? Because some of the voltage are being used in the battery because the battery has got an internal resistance. So some of the voltage are being used in the battery. Okay, this is how you are going to answer this question for 2 marks. You are going to say energy per coulomb of charge. This is voltage. Okay, energy per coulomb of charge is converted to it in the battery due to the internal resistance. Okay, some of the energy per coulomb of charge. Remember, potential difference is equal to energy per coulomb of charge, or is equal to work done per coulomb of charge. Okay, work done is equal to energy transferred. Okay, now let's answer question 8.3. Remember, you are told the reading on the voltmeter decreases by 1.5 volts when switch S is closed. So 8.3, calculate the following when switch S is closed. Okay, you have 8.3.1. You have to calculate the reading on the ammeter. Okay, let me get the question. 8.3 now. Okay, so this is what you are given. You have to calculate the following when switch S, okay, when switch S is closed. Okay, when switch S is closed, calculate the reading on the ammeter. Okay, you can see the ammeter is reading the total current. Okay, you have to see that. Let me show you. So from the battery, the current is coming, okay, total current will flow through the 4 ohms resistor. It's carry on. It's going to flow through the ammeter. So you can see the ammeter is going to read the total current. Okay, so when the total current reach this node, the current is going to divide. Okay, the current is going to divide. Some of the current will flow through the 25 ohms resistor, and some of the current will flow through the 15 ohms resistor, and then they will join at this node. Okay, and then back to the battery. Obviously, when the switch is closed, okay, when the switch is closed, you are going to have the current flowing this way. Okay, so you can see the ammeter is going to read the total current. Okay, so we have to find the total current. There are many ways that you can use to solve this question. You can see this is your internal voltage. Okay, internal voltage. What is lost? Okay, V lost. V lost is the internal voltage. Okay, you are told the voltmeter reading decreases by. So this is what is lost, the internal voltage. So you can use this formula if you want, because you have the internal voltage and you have the internal resistance. Okay, this is what is lost inside of the battery. Okay, the voltmeter reading decreases by 1.5 volt. Okay, this is what is lost, the internal voltage. So with this formula, since we know the internal voltage and we know the internal resistance, we can find the total current coming from the battery. Okay, so you have the internal voltage 1.5 and you know your internal resistance 0.5. Okay, so you can calculate current. Okay, so this is equal to 1.5 equal to, you have the current times 0.5. You are going to divide by 0.5 on both sides. When you divide by 0.5 on this side, you are going to have current is equal to, you also divide by 0.5 on this side, you are going to have 1.5 over 0.5. This is equal to, you are going to have 3 amperes. Okay, you can check with your calculator, 3 amperes. So this is the total current coming from the battery. Okay, now the next question, 8.3.2. calculate the total external resistance of the circuit. Okay, external meaning outside. So this is external resistance. Okay, external resistance, not the internal. We want the external, total external resistance. Okay, outside of the battery, you have this, and this, not this. This is internal, inside of the battery. Okay, so you have R1 is in series with this combination. Okay, you have this combination, right? You have this combination, which is a parallel circuit. You have R1 in series with this combination. So the total resistance of the external circuit you are going to have R1 plus, now you have this, which is a parallel circuit. Okay, you can do this. You have 1 over R2 plus 1 over R3. You close your bracket, you raise everything to the power of -1. So you have to do this. You have to do this so that you don't have to flip when calculating the resistance for the parallel combination. So let's calculate. You are going to have the total external resistance is equal to R1 is 4 plus, in bracket, you have 1 over R2. R2 is 25 ohms plus 1 over R3. R3 is 15 ohms. You close your bracket to the power of -1. Do not forget this. Okay. Now, let's find the answer. This is equal to, you can use your calculator. You have 4 plus, in bracket, 1 over 25 plus 1 over 15 to the power of -1. Okay. You are going to have 13.375. 13.38. Okay. To 2 decimal places. 13.38 ohms. Okay. If you want, you can find the resistance for the parallel combination first, and then you are going to add the 4 ohms. If you want, you're still going to find the same answer. Okay. Or you can combine everything like this. Make sure you don't forget the exponent -1. Okay. Now 8.3.3. Calculate the EMF of the battery. Okay. You can use this formula because you have the current, you have the total external resistance, and you have the internal resistance. So you can use this formula, or you can use other method. Okay. So the EMF is equal to, you have the total current, the total external resistance, okay, plus the internal resistance. The EMF is equal to 41.64 volt. Okay. Now 8.4. Okay. 8.4. Elena makes the following statement. The current through resistor R3 is larger than the current through resistor R2. Is the statement correct? Choose from yes or no. Explain the answer. This is yes. Why? The current through resistor R3. R3. This is 15 ohms. Is larger than the current through resistor R2. This is 25 ohms. So the larger the opposition, the smaller the current that is going to flow through the resistor. The smaller the opposition, the larger the current that is going to flow through the resistor. So R3 is smaller. Okay, 15 ohms. The current will be larger because the opposition is smaller. Okay, so you have a total current coming and then splitting. Okay, you are going to have a larger current flowing through this resistor and a smaller current flowing through this resistor. So the current flowing through R3 is larger than the current flowing through R2. Okay, so the way you are going to explain this question, because you are requested to choose from yes or no and then explain. Okay, so you are going to say for the same voltage or for the same potential difference. Remember, you have a parallel circuit. Let me show you. You have a parallel circuit. So the voltage across this branch is the same as the voltage across this branch, because this is a parallel connection. The voltage across each branch is the same. This is why you are going to say for the same voltage or for the same potential difference, you are going to have a larger current will flow through a smaller resistor. Okay, a smaller resistor. You can see the value. You are going to have a larger current flowing through a smaller resistor. Okay, and you have to show this using this formula from Ohm's law. Okay, the current, we are talking about the current. The current is equal to the voltage over the resistance. Okay, this formula is obtained from Ohm's law formula. Okay, the current is equal to voltage over resistance. So you have the same voltage across each branch. When the resistance is greater, when you have division by a big number, you are going to have a smaller current. But when you have a division by a smaller number, you are going to have a larger current. Okay, now question 8.5. The 4 ohms resistor is now removed from the circuit. Okay, you now remove the 4 ohms resistor. Now, how will this affect the EMF of the battery? Choose from increases, decreases, or remains the same. Okay, the EMF does not depend on what is connected to the battery. Okay, this is a function of the battery. The EMF will always be constant. Okay, so remains the same. Okay, we are done with this question. Okay.